Questions 21 to 25 on the 2005 grade 10 AMC 10A. For how many positive integers does 1 plus 2 all the way up till n evenly divide 6n? So 6n divided by 1 plus 2 plus all the way up till n has to give an integer. And that's what it means to evenly divide something. Well, there's a formula, as I'm sure you may know. 1 plus 2 all the way up to n is n times n plus 1 over 2. So therefore this becomes 6n over 1, invert and multiply, n times n plus 1. And this becomes 12n over n times n plus 1. And therefore this becomes 12 over n plus 1, like that. And therefore we've got to figure out when is that an integer. So let's make a table and let's see what we get. So we got n here and we've got 12 over n plus 1 here. And I'm going to figure out for n all the way up till 11. Because once you get to n equals 12, it'll be 12 over 13 and so on, right? And those values are always going to be fractions. They can never be integers when the denominator is greater than the numerator. All right, n equals 1, we get a value of 6. When n equals 2, we get a value of 4. When n is 3, we get 3. When n is 4, we get 12 over 5. When n is 5, we get 12 over 6, which is 2. When n is 6, we get 12 over 7. Then 12 over 8, 12 over 9, 12 over 10, 12 over 11, and finally we get 12 over 12, which is 1. So how many times did we get an integer? We got it these times. And that would mean 1, 2, 3, 4, and 5 values of n give me integers. So number 21, the answer is B. Let S be the set of 2005 smallest positive multiples of 4 and T be the set of the 2005 smallest possible multiples of 6. How many elements are common to S and T? Well, 4 is the multiple. So 4, 8, 12, ... all the way till 2005 times 4, correct? Because this is basically 4 times 1, this is 4 times 2, this is 4 times 3. So you're eventually going to go until 4 times 2005, right? So what is 4 times 2005? It's 8,020. And now let's turn our attention to the multiples of 6. We've got 6, 12, 18, ... like that, all the way till the 2005 multiple. So that'll be basically 6 times 2005, like that. And that is 12,030. Because this is 6 times 1, this is 6 times 2, and this is 6 times 3, and so on. Okay, so these are our numbers. Now, what elements are common? Well, first and foremost, what is 4? 4 is basically 2 times 2, correct? And then what is 6? It's 2 times 3. So what is the common multiple for, least common multiple for 4 and 6, LCM? Well, 2 has to be used at least twice, because that's the maximum. And 3 has to be used at least once, because that's the maximum number of times. So 2 times 2 times 3 is 12. The least common multiple is 12. So any multiple of 12 in each set will be appearing twice. And we already see that 12 is there twice. So any multiple of 12. So this number goes as high as 8020, and that's as far as it goes. So we just need to be worried about all the numbers from 4 until 8020. That is a multiple of 12. And you just have to divide. And you take the integer value. That's what the symbol means. And if you do that, you get 668. And that's the answer. So number 22, the answer is D. Let AB be the diameter of a circle and C be a point on AB with 2AC is equal to BC. Let D and E be points on the circle such that DC is perpendicular to AB and DE is a second diameter. What is the ratio of the area of DCE to the area of ABD? Okay, DCE. So first and foremost, I'm going to need a height. So I'm going to draw a line from E to this point right here. That point like that. And I drew it in a way so that it's parallel to that line. So this is a right angle. Okay? And therefore, if I were to first write this question out, they want us to figure out the ratio of triangle DCE's area to triangle ABD. Now DCE, 1/2 base times height, if I use this as the base and I use this as the height, I'll call this F, this point, so I'll call that EF. And then ABD, this is the base, so 1/2 AB, and I'll use this as the height DC. So you quickly see that a lot cancels. The only thing we get left is EF over AB, like that. And yeah, so we will have to figure out somehow a numerical value for EF and a numerical value for AB. All right, let's go back to the question and see what kind of clues we can get. This one is very important. 2AC is equal to BC. So if this is X, BC is going to be 2X from here to here. So I'll just put 2X up there. And then we are also told that DE is a diameter. Right there. DE is a diameter. So if DE is a diameter, then it is equal to AB. And AB is equal to 3X. Correct? Or the way I labeled it. So that means DE is also equal to 3X because it's also a diameter. Now therefore, what's the radius? The radius is the diameter divided by 2. So it's 3X divided by 2. All right? And one last thing is this little guy right here, from here to here, from the center until C. I'll call the center O. So this, I need that distance. Can I figure out that distance? Sure. Basically, from here to here is the radius, correct? From the center to the edge of the circle. And then from here to here is the X that I labeled. So from C to O will be the radius minus X. So CO will be the radius minus X. And the radius is 3X over 2 minus X. And this becomes X over 2. So I'll just squeeze that in there, X over 2. All right. Now we proceed with this question with something that you probably already saw, which is similar triangles. This triangle is similar to the big triangle, this one. All right? So that means that triangle DCO is similar to triangle DFE. And therefore, if the triangles are similar, the ratio of the sides are the same. So DO over CO is the same as DE over EF. So DO, what is it? It's the radius, so that's 3X over 2. CO, we just figured out, X over 2. DE is the diameter, so that's 3X. And EF, we don't know, so we have to solve for EF in terms of X, obviously. All right, let's figure this out here. 3X over 2 Invert and multiply. 2 over x is equal to 3x over EF. Like that. Let's see here. The x is canceled, the 2's canceled, so we're just left with 3 is equal to 3x over EF. EF, therefore, is 3x over 3, and that's just x. Okay. All right. We have everything that we need. So going back and turning back our attention to that, EF we just figured out was x. AB is from here to here, which is the diameter, which is 3x. And therefore this is just 1/3. And therefore number 23, the answer is C. For each positive integer m greater than 1, let Pm denote the greatest prime factor of m. For how many positive integers n is it true that both p to the n is equal to the square root of n and p to the n plus 48 is equal to the square root of n plus 48? So if we have a number, any number, let's say I choose 10, p to the m, if this is my m, is the greatest prime factor. Well, what are the prime factors, first of all, of 10? Well, it's 2 times 5, correct? So the greatest of these 2 prime factors is 5. All right, does that make sense? I hope so. So they're saying that p to the n is equal to the square root of n. That's the first part of the condition. All right, so this takes a little bit of thinking. What does that mean? Well, if m is equal to, you can make a table, right? And you can kind of do this one by one. So if you make a table of m, or actually let's use n. So we have m, we've got pn, root n, and then pn plus 48, and n plus 48. So first I'm just going to concentrate on the first 3. All right, let's start filling in values and see what we get here. Let's say we have 2. Well, the greatest factor or prime factor of 2 is just 2, and the square root, and therefore is root 2. Okay, well, this definitely does not equal that. Let's say we have 3, the greatest prime factor is 3, and this will be root 3. Okay, how about 4? Greatest prime factor of 4 is 2, and the square root of 4 is 2. Well, there you go. We got 1. We haven't looked at these yet, but at least the first part we have matched one value, and that happens when m is equal to 4. And if you keep going like this, you'll find a pattern that once you get to 3, it will also work. And then it will also work when you get to 25. And it will again work when you get to 49. And so on. 121 it will work. And you say, well, okay, I see that this is working, but what is the criteria therefore? The criteria is that n is a perfect square. I hope you can see that. Each of those values of n where this worked, n was a perfect square. And the other criteria is that the root of n is a prime number. Do you see that? 2, 3, 5, 7, 11. That's the only way this can work, because prime numbers will only have one possible factor. Okay? So now let's turn our attention to the second part. And that is they want Pn plus 48 to be equal to the root of n plus 48. Okay? So for example, if you're using 4 for n, this would be P of 52. And this would be the square root of 52. Well, the P of 52, if you were to break that into prime factors, it would be 13 times 4, which is 13 times 2 times 2. So that would be basically 13. And the square root of 52 is obviously not 13, it's 7 point something. So these are not equal. Let's see what we get if we continue with this list. If n is 9, we would get P of 9 plus 48, which is 57. And since 57 is 3 times 19, the greatest possible prime factor is 19. Now what about the square root of n plus 48? Well, that's root 57, and that's obviously not equal to 19. Okay, let's continue with n equals to 25. Let's see what we get. We got 25 plus 48, and that's P of 73. And 73 being prime, therefore P of 73 is just 73. And therefore 25 plus 48 over here becomes root of 73. And obviously the root of 73 is not equal to 73. So let's try 49. We got 49 plus 48. So that gives me the P of 97. 97 is a prime number. So that means that the biggest prime factor is just 97. And therefore n plus 48 square root is the square root of 97, and that's obviously not equal. Let's try 121. We got P of 121 plus 48. And that is the P of 169. Well, 169 is 13 squared, so that's 13. And then n plus 48 would be the square root of 169, and that is 13. So there you go. We've got a match. And this is the only match. If you keep going, you'll find if you use larger perfect squares such as 169 and 289 and so on, that you won't get another solution. So those are only one solution, and that happens when n is equal to 121. So number 24, the answer is B. In triangle ABC, we have AB equal to 25, BC is 39, and AC is 42. Points D and E are on AB and AC respectively, with AD equal to 19 and AE equals 14. What is the ratio of the area of triangle ADE to the area of quadrilateral BCED? So first, let's draw our diagram. Let's say we've got some triangle in here. We don't know exactly what it looks like, but let's say it looks something like this. And let's start labeling our sides. A, B, and C. And they're saying this is 25, this is 42, and this is 39. And some point on here is D, AB, and some point on AC is E. So this is E, and this is D. And they're going to draw a line from D to E like this. And they want you to figure out, in the end, a ratio between triangle ADE over the quadrilateral BCED, like that. Well, I immediately noticed that if you have a quadrilateral BCED, that's basically the full triangle ABC minus ADE. Correct? All right. Okay, so how do we do this? Well, they gave you some clues here. AD, that's going to help us tremendously, I think. AD is equal to 19, and AE is equal to 14. So I can fill in the other side, since it's 25 here, the whole side. This is going to be 6 from D to B, and E to C is going to be 28. Okay. All right, here we go. Now the first thing I want to do is I want to draw a little bit of a line segment that's going to help me. And that's from B to E, like this. Okay, I think I have everything I need to move forward. Here we go. The first thing is looking at triangles ADE and ABE. Now I want you to understand this, so I'm going to draw a height to show you how this can be arranged. This is my height, my perpendicular distance from E to the base, and I'll call that H1. Okay, H1. Now let's figure out the area. ADE, 1/2 base. What is the base of AD? It's 19, correct? Times height, well the height I just drew, H1, all over ABE. ABE, the base is 25, 1/2 times 25, and it has the same height. So this just boils down to 19 over 25. All right? And in a very similar way, I will compare ABE to the full ABC. And before that, I do that, I will draw a very similar type of height from B down to the bottom to make that a perpendicular. Okay, I'll call that H2. Okay, so ABE, the base is 14, 1/2 base times height, height is H2. ABC, the base is 42, 1/2 base times height, and the height is H2. So in a very similar way, we get 14 over 42. All right, which is, I think that's 1/3, right? Yeah. Okay, great. So now we can look at ADE and ABC. And that's very helpful because that's the triangles that are in our big ratio that we have to find. Well, I'm going to use what I just figured out. AD over ABC is essentially ADE over ABE times ABE over ABC. Correct? Because these two will cancel. And this guy I already know is right here, 19 over 25. And this value I also know is 1/3. So there you have it. We got 19 over 75. And now we can solve for our ratio. So the ratio that I want is ADE over ABC minus ADE, like that. Now what I'm going to do is I'm going to flip this. It makes it a little bit easier for me. If I do that, watch what happens. I get ABC minus ADE over ADE, like that. And this helps a lot because 1 over R now becomes just ABC over ADE minus 1. See how that helped there? So ADE over ABC I just got was 19 over 75. So that means 1 over R is equal to ABE over ABC is 19 over 75. So if you flip it like that, it's actually 75 over 19 minus 1. So 1 over R is therefore 75. Get a common denominator here, 19, 19. 75 minus 19 over 19, which is 56. And therefore, the final step is you got to flip it to get R. And that's 19 over 56. R, of course, being our ratio. And there you have it. That's the answer. So number 25, 19 over 56 is D.